Hey everybody, Harold here. Today I want to talk to you about joins in Polars data frames. First, I want to point out a huge problem between joins in pandas versus joins in polars. Joins in pandas can produce errors or the wrong results due to joining on indexes. Due to joining on indices, polars forces correctness. It's faster, simpler, and more scalable. Let me show you what I'm talking about. Got my Colab notebook open. I'll put a link to it in the description so you guys can follow along or do it on your own. I've imported pandas as PD, made a small data frame of customers, name and city, and the index represents the customer ID, but it's not obvious. Most people would use the index as the ID in pandas. And then orders, I put this data in here, but somebody filtered or sorted it, and you didn't know about it, and it reset the index. So it looks innocent when you join it on the index. I'll show you. Result equals customers.join orders. Okay, so I have 0 Alice, customer city, New York City. That's correct. Customer ID is 2 and index is 0 because somebody messed with it. That's not right. Uh, Polars, on the other hand, forces you to put in here in my customers database customer ID because there is no index in Polars. So I have 0, 1, 2 there for Alice, Bob, and Charlie, and a corresponding orders data frame. Let me print that. Um, Alice, even though it's been resorted, it's still at 0, so the join is correct. Alice in Pandas has moved to customer ID 2, index 0. That is incorrect. And I had to create a customer ID column and not just rely on the index for joining. Alice should be 0, but it turned into 2, and you would never know when you're running this program, especially if it had millions of rows, and your index would be, and your join would be corrupted. So that's a huge issue. Let me get on to the general differences. Uh, Polars has better syntax clarity. It always uses join, not join or merge or whatever else Pandas uses. And it's always on a column and how to join them. So everything's more consistent. Pandas overloads, it uses merge, join, and index joins, which creates a lot of ambiguity, especially when you're using those index joins like I showed above. Performance, Polars is fast, it uses a Rust engine. You can do parallel joins, multi-threading. You just columnar memory layout, which is faster, and it consistently uses null for any missing values. Pandas, on the other hand, is based in Python, it's single-threaded in most cases. It's row-based and indexed, which created the problem we showed before. And for different data types, it mixes NaN, none, and NAT. So the null consistency is not the same as in polars, where everything is null. Um, you could say pandas is just table manipulation in Python. Polars is a SQL engine, SQL query engine. So let's get on with the joins. I've imported Polars as PL and created 2 data frames, customers with ID, name, and city, and orders with order ID, customer ID, amount, and order date. I want to print both of those to show you. So there they are. Customer ID, name and city, and customers, order ID, customer ID, amount, and order date, and we're going to join on customer ID. There's two kinds in joins in Polars, equi joins, just based on exact matching values, and then there's non-equi joins, which can be conditionally based or based on, say, the nearest value, nearest matching value. Uh, Inner join only matches rows where there's a matching entry in both data frames. So we say inner equals customers.join. Table we want to join two orders. The column we want to join on customer ID. How we want to join it, inner. And I'll print inner. So every order and customer that had an order, those orders are displayed. Yes. So we have customer ID, name, city, order ID, amount, order date. So everything that's an order from this table is represented on that table. Order number 105 is not there because there is no customer ID 6 in the customers table. So that's an inner join. You could limit it to just columns you want by adding a dot select statement. So I'm going to join them again, just include name and amount, print enter. So there you have Melvin, his total amount for the order, so on and so forth. And these joins are just like in SQL. The left joins all rows from the data frame, the left data frame, inserts nulls for non-matching right rows, and only nulls, not nans or nats. So left equals customers.join orders on customer ID, how equals left. So there's all customers from the left data frame, and the matches on the right, and if they don't have any, there is a null in the order ID, amount, and order date column. Right is the reverse of left. You could just switch your column names from the on to the join. You can do a right. All rows from the right data frame with nulls for non-matching left rows. So right equals customers.join orders on customer ID, how, right. And then we have that customer 6, that order, customer ID 6, we don't know their name and city. We get nulls for them. Full outer returns all rows from both data frames with nulls with no match. So full equals customers.join orders on customer ID, how equals full. We'll print full. And we've got everything. And where we didn't have the information, it put a null in consistently. And notice here, there's a new column called customer ID right, which holds all the customer IDs from the right table, the orders table. Um, to understand that behavior, when you join two data frames on the column customer ID, you notice you get customer ID and customer ID right. Because both data frames contain a column with the same name, the full join needs to preserve both sources. There may be rows that don't have matches, so you get customer ID from the left data frame, and Polars creates customer ID right from the right data frame. It helps you identify the origin of each value after you join the tables. And if you want to avoid duplicate key columns and force them into a single unified column, you can enable Coalesce equals true. In these cases, you typically get a single customer ID column instead of left-right versions. Enter left and right coalesce keys by default. So duplicate key columns appear to preserve the data origin. Coalesce equals true can simplify the output by merging them. And the default's usually coalesce already when it's appropriate. So let me show you a coalesce equals true version of that full join. Now you still have all the information, but you don't have that additional customer ID right if you don't want it. A semi-join rows gives you rows from the left data frame which have a match in the right. In other words, customers with orders. So semi equals customers.join, orders on equals customer ID, how equals semi, print semi, and Melvin, Jose, and Kim all have orders. Penny and Noah do not. So that's the semi-join. The opposite of that is the anti-join. Rows from the left which don't have a match on the right. In other words, customers with no orders. So anti equals customers.join orders on customer ID, how anti. And then you've got Penny and Noah who don't have any orders. So if you want to do a quick check to see who hasn't ordered lately or something, you could run an anti-join. You could join on columns with different names. To illustrate, I renamed customer ID to cust ID in orders data frame. Let me just show you that just used orders.rename customer ID custom cust ID underscore ID. And we'll print that just to show you. So now orders has cust ID, not customer ID. So we're going to join orders left on customer ID, right on cust ID. So you have to tell it now which one's the left and the right table, and how equals enter. When you do this, Polars automatically keeps the left data frame column name, not the right. So we have customer inner join with customer ID and no cust ID because by default it coalesces. I mentioned before non-equi joins, conditions other than equality, and Polars has a join where clause, just like SQL. So I created two new data frames, products with a min and max price, and sales with a sale ID and a price. And this is kind of just fake data to illustrate my point. I'll print sales and products. So sale 4 here has 1,000. That's above the max price for any sales. You want to find this where the sales price is in the product price range. So you would say our non-equi df equals sales.join where have products. PL.call price is greater than equal to PL.call min price, and PL.call price is less than or equal to max price. So everything should come up except for that $1,000 sale number 4. Sale ID number 4 is not in here because it's not in the range we specified. You can do an AsOf join. AsOf matches on the nearest key. You typically use this with time data. Finds the closest match that is less than or equal to the key. So stock prices, we have a data frame for those, their timestamp and the price. The trades, we have a timestamp for those, and we have the volume. And this is just date formatting, string print time to make the dates look nice. Let's just show you those. So here we have timestamp, price, with 5, 10, and 15-minute intervals, and the actual times were 9:03, 9:07, 9:20, and 9:35. We want to find the price at or before the timestamp. So as of equals trades.join as of on the prices data frame. On the timestamp column, strategies backward, we want to find at or before the timestamp. So let's print that. So we want to find trades, what the price was at or before the current timestamp. So the order with 100 came in at 9:03. It gets the price at 9 o'clock. The order with 200 came in at 9:07. It goes backwards and gets the price at 9:05. The order with 9:20 came in 101, gets the price from 9:15, and the order at 9:35 comes in, gets the price, comes in. The order at 9:35 comes in at 103.5 because it went backwards and got the price at 9:30. So that's an as of. You can do as of with tolerance and only match if it's within a certain time range. So as of tal_tal equals trades.join as of prices on timestamp strategy backward tolerance is 2 minutes. So we'll print the as of tolerance. So nothing happened within 2 minutes of 9:03 backwards. It's 3 minutes to 9 o'clock. 9:05 to 9:07 is 2 minutes, so that showed up. The order that came in with 9:20 is not within 2 minutes of 9:15, and the order that came in at 9:35 is not within 2 minutes of 9:30. So you can set the time range also with that, using as of with a tolerance argument. Uh, you can do a Cartesian product, which is cross join all rows from both data frames, all possible combinations of all rows from both data frames. So I made a small colors data frame with sizes. You want to know all combinations of colors and sizes of your product, say t-shirts. Cartesian equals colors.join sizes, how equals cross. We'll print that. So you have red, small, medium, large, and blue, small, medium, large. So you know all your combos. If you want to join on more than one column, you can do that also. Here's another small data frame with department ID, employee ID, and name. Department ID, employee ID, and salary. Print those. There we go. Uh, you'd say multi-join equals employees.join, salaries on. Here you use a list. Department ID, comma, employee ID, how equals left. When you print that, you get them joined on department ID and employee ID with their name and salary if they have one. So that is joins and polars. Um, they're a lot better in pandas. They're faster. You avoid the mistakes we made up here where got the wrong ID to join on, and you never know about it. So I hope you liked this video. If you did, please like it, subscribe, and I will see you next time. Thanks, everybody.